Next is screening effect or shielding effect. So this shielding effect or screening effect comes for multi-electron system. Multi-electron system. That means an atom having more than two electrons. Have taken three shells. Rather, let us assume that these are the orbital itself. So the last one is known as valence shell or outermost shell. Outermost shell, or we can also call it as valence shell. Whatever the electrons are there, that's known as valence electrons. Valence electrons. If you consider this particular shell, this is known as penultimate shell. Penultimate shell. And the other one should be anti-penultimate shell. This is nothing but anti-penultimate shell. Anti-penultimate shell. Our basic understanding is between an electron and nucleus, there is attractive force. Always there is a attractive force. Between electron and electron, there is always a repulsive force. In multi-electron system, we have two types of forces. One is attractive force between electron and the nucleus, and the electron and electron, repulsive force. If a system is said to be stable, or if an atom is said to be stable, net attractive force should predominate. Attractive force should be dominant. Now, when we speak of shielding effect, we tell with respect to the valence electrons. With respect to the valence electrons. We know that this valence electrons are trying to attract it towards the nucleus. That means nucleus wants to have control on the valence electron. So, how much this nucleus can control the valence electron? That depends on this penultimate and anti-penultimate electrons. So, these are known as what? Inner electrons. These are known as inner electrons. These electrons are there in a given orbital or a subshell. Now, if this inner electrons covers the valence electron effectively, so these are the valence electrons you have. What does this inner electrons are doing? They are forming a protective layer around the nucleus. Around the nucleus, they want to cover it. So, when this inner electron covers the valence electron, as a result, the attractive force between the outermost electron and the nucleus, between these two, there is a decrease in attractive force. Attractive force decreases. Attractive force decreases. As a result, there is no change in the size of the atomic orbital. There is no change. The size of the atom will not change because the attractive force is proper here. Why the attractive force is proper? Because the inner electrons are shielding properly. Here the shielding is proper. When the shielding is proper, the attractive force between the valence electrons and the nucleus is getting decreases. Therefore, we can also say that the effective nuclear charge, we can say that effective nuclear charge is lesser in this case. Why less? Because the inner electrons are protecting. Suppose, on the other hand, assume that assume that these inner electrons are not covering the valence electrons effectively. As a result, this is not protecting properly. The nucleus is not protected by this penultimate and anti-penultimate electrons. As a result, the valence electrons are trying to attract towards the nucleus. There is more attraction between the valence electrons and the nucleus. In this case, since the attractive force is more, the size of the atom goes on decreases. Slightly there is a decrease. Therefore, here the size decreases. Size of atom, atomic size. Atomic size decreases. Why atomic size is decreasing? Because the effective nuclear charge is getting increased. What's the meaning of effective nuclear charge? The total positive charge experienced by the valence electrons, meaning how strongly the nucleus can pull the valence electrons effectively. That is measured in terms of effective nuclear charge. If the effective nuclear charge is more, means more attraction between the nucleus and the valence electrons. That's known as shielding effect. Okay, if the shielding effect is more, then the size become as it is. Effective nuclear charge will be less. If there is a poor shielding, the size of the atom decreases, the effective nuclear charges increases. The next question comes: which can shield the outermost electrons effectively? The order is this: S, P, D, F. S subshell can shield it properly. So therefore, this is good shielding. Good shielding. So F will have complex structure, that is cuboid. A cube cannot cover the spherical surface effectively. As a result, the screening will be lesser for F orbital. F, D.